Have you ever reached for a spice on your kitchen shelf, one that costs almost nothing, and wondered whether the thing you were sprinkling into your food might actually be doing something quietly extraordinary inside your body? Not the obvious spices, not the expensive ones, one of the cheapest, most ordinary ingredients sitting in your pantry right now. For thousands of years, across kitchens and temples and traditional medicine systems, this spice was treated as something almost sacred. In modern laboratories, it has become one of the most studied molecules in nutritional science. Yet most people sprinkle it on a stir fry twice a month, never knowing what it is doing, never knowing why the form they take changes everything, and never knowing the specific partner compound that flips the entire outcome. I want to be honest with you right at the start. This is not the video where I tell you to take a teaspoon of this spice every morning and call it a cure for inflammation. I find that kind of content genuinely frustrating because the actual biology of what happens inside a human cell when this compound crosses your gut wall is so much more interesting than a wellness tip. And some of the wellness advice you have seen about this spice is flat out wrong in ways that matter. What I want to do today is walk you through what is literally happening at the molecular level when this compound enters your bloodstream, what it does to inflammatory signaling, what it does to your gut microbiome, why the form you take and the partner compounds you combine it with change the outcome by orders of magnitude, and why the dose most influencers recommend is, in many cases, doing almost nothing. And then by the end, the picture of how this ordinary spice becomes genuinely extraordinary is going to feel completely obvious to you, not because I told you so, but because you will see the mechanism. The spice is turmeric. The molecule is curcumin, that bright yellow powder in a tiny jar at the back of your spice rack. Let me start with inflammation, because that is the headline claim, and we need to pull it apart carefully. Inflammation is not a bad thing. When you cut your finger, inflammation brings immune cells to the cut. When you catch a virus, inflammation coordinates the immune response that clears it. The problem is not inflammation itself. The problem is chronic, low-grade, unresolved inflammation, the kind that quietly drives cardiovascular disease, metabolic dysfunction, and joint pain over years. That kind of inflammation runs on a specific molecular switch called NF-kappa B, nuclear factor kappa light chain enhancer of activated B cells. This is the master regulator of the inflammatory response. NF-kappa B lives in the cytoplasm of almost every cell in your body, and when it gets activated, it translocates into the nucleus, binds to DNA, and turns on hundreds of genes that produce inflammatory cytokines, the chemical messengers that drive chronic disease. This is where curcumin enters the story, and I want you to hold on to this part. In 1995, a research group at the University of Texas MD Anderson Cancer Center, led by Professor Bharat Agarwal, published a paper in the Journal of Biological Chemistry with Sanjay Singh as lead author. What they showed was that curcumin directly inhibits the activation of NF-kappa B. It blocks a specific step in the signaling cascade that occurs before a critical protein called I-kappa B alpha gets phosphorylated. This is not a vague wellness claim. This is a specific molecular interaction with a specific transcription factor, demonstrated in a controlled laboratory setting and replicated dozens of times since. Subsequent work by Shishodia and Agarwal in 2005 extended this finding, showing that curcumin also downregulates constitutively active NF-kappa B and inhibits the kinase IKK, the enzyme that sits upstream of NF-kappa B activation. I want to slow down here because the significance of this is easy to miss when you read it as a list of acronyms. Almost every anti-inflammatory drug you have ever taken works downstream of NF-kappa B. Aspirin blocks COX enzymes. Ibuprofen blocks COX enzymes. Steroids broadly suppress immune output, but curcumin targets the master switch itself. It sits upstream of the entire inflammatory gene expression program. That is a fundamentally different mechanism. Not better, not worse. Different. And here is where the wellness content goes wrong, and where this conversation gets genuinely complicated. There is a problem with curcumin that has confused and frustrated researchers for decades. Curcumin has extraordinarily poor bioavailability. When you ingest curcumin on its own in the dosages that wellness blogs typically recommend, somewhere between 500 and 1,000 milligrams per day, very little actually reaches your bloodstream intact. It gets rapidly metabolized, it gets conjugated, it gets excreted. Plasma concentrations of free curcumin after a typical oral dose are vanishingly small. This has led to a peculiar situation. The molecular evidence says one thing. The clinical evidence sometimes appears to say another. Because the molecule clearly works in a petri dish, it clearly works in a mouse. But in a human, the form you take and what you combine it with changes the outcome by an order of magnitude. And this is where a partner molecule changes everything. In 1998, a researcher named Shoba and her colleagues published a study that became one of the most cited papers in the curcumin literature. The finding was this. When you co-administer curcumin with piperine, the active alkaloid in black pepper, the bioavailability of curcumin in humans increases by 2,000% at 45 minutes after ingestion. 2,000%, not 2%. 2,000. Let me explain why piperine does this because the mechanism is precise. Piperine inhibits several enzymes in your liver and intestinal wall that metabolize curcumin into inactive forms. Specifically, piperine inhibits glucuronidation, the process by which your body tags curcumin with glucuronic acid to make it water-soluble for excretion. It also inhibits certain cytochrome P450 enzymes that would otherwise break curcumin down. The result is that more intact curcumin survives the journey from your gut to your bloodstream and stays intact long enough to interact with NF-kappa B inside your cells. This is the part that wellness content almost never tells you. The turmeric in your spice rack works very differently from the turmeric in a clinical trial. A teaspoon of turmeric powder sprinkled on your dinner contains roughly 200 milligrams of curcuminoids total, and an unpredictable fraction of that actually reaches systemic circulation. So when someone tells you, just take turmeric, it works, they are telling you roughly half the story. The molecule works. The mechanism is real, but your kitchen spice jar is not a clinical dose. Let me now turn to the clinical evidence because I want to be careful here. The strongest human evidence for curcumin is in joint health and arthritis. A 2016 meta-analysis by James Daly and colleagues published in the Journal of Medicinal Food reviewed randomized controlled trials and concluded that turmeric extract providing approximately 1,000 milligrams of curcumin per day showed efficacy in arthritis symptom reduction comparable to non-steroidal anti-inflammatory drugs with a better safety profile. A specific trial I want to mention is the 2012 pilot study by Binu Chandran and Ashok Goel, published in Phytotherapy Research. 45 patients with active rheumatoid arthritis were randomized into 3 groups: curcumin alone, curcumin plus diclofenac, a common NSAID, diclofenac alone. The curcumin group showed the highest improvement in disease activity scores. The curcumin plus diclofenac group showed no additional adverse events compared to diclofenac alone, suggesting a possible synergy. 45 patients is a small study. It is a pilot. It is not the kind of multi-center, large sample trial that would change clinical guidelines. But the signal was real, and it pointed in the same direction the mechanism predicted. Now let me bring in the gut, because this is where turmeric's story connects to the broader conversation about how your daily choices shape your internal environment over years. Curcumin interacts with the gut microbiome in ways that have only recently become clear. There is a particular bacterium I want to introduce you to. It is called Akkermansia mucinifila, and it lives in the mucus layer that lines your gut wall. It feeds on mucin, a glycoprotein that is part of your gut's protective lining, and its activity actually stimulates your gut to continuously produce fresh mucus. So, like a maintenance crew whose presence causes the renovation they are responsible for. Higher abundance of Akkermansia has been associated in studies from the laboratory of Patrice Canny at the Université Catholique de Louvain in Belgium, with lower rates of metabolic syndrome, insulin resistance, and lower body weight. A 2020 review by Skazacchio and colleagues published in Nutrients examined the interaction between curcumin and gut microbiota in detail. What emerged is that curcumin appears to modulate the composition of the gut microbiome in a bidirectional way. It influences which bacteria thrive in your gut, and at the same time, your gut bacteria metabolize curcumin into active metabolites that may have their own biological effects. Animal and in vitro studies have shown that curcumin supports the growth of Akkermansia mucinifera specifically. So, turmeric's effects on metabolism and inflammation are not just direct molecular action in your cells. They are partly mediated through reshaping the community of organisms inside you. I want to stop on this for a moment because it lands differently when you really sit with it. The turmeric is not just acting as a chemical, it is acting as an ecological signal. It is reshaping an ecosystem that lives inside your body, and that ecosystem in turn shapes your metabolism, your immune calibration, your mood chemistry. The spice is part of a system response, not a single input. Now, let me talk about what is sometimes called the bioavailability gap and where reasonable people disagree. Some researchers argue that the totality of the clinical evidence on curcumin is weaker than the molecular evidence suggests. The argument goes like this: the in vitro data is overwhelming. The mechanistic data is real. The small human trial data is generally positive but inconsistent. Several meta analyses have noted that the heterogeneity across trials, the different formulations used, the different doses, the different populations studied, makes it genuinely difficult to draw confident conclusions about specific clinical applications. That criticism is fair. It is also the criticism that responsible science should receive. It does not cancel out what we actually know. We know curcumin interacts with NF-kappa B. We know piperine increases its bioavailability by 2,000%. We know stronger bioavailability formulations have produced meaningful results in arthritis trials. We know the molecule modulates the microbiome in directions consistent with its known mechanisms. We also know that popping a turmeric capsule bought off a wellness website using whatever dose the label prints is not a careful intervention and may not produce measurable effects. What I am not going to do in this video is tell you how much to take. I am not a clinician. Individual responses vary. The right approach for you is a conversation between you and your doctor, not a YouTube video. What I can do is give you the underlying mechanics so that if you decide with your doctor's input that you want to include this in your routine, you understand what is actually happening and what to look for. Let me now talk about safety, because it is more nuanced than the wellness community suggests. For most people, culinary amounts of turmeric are well tolerated and have been consumed for centuries. Higher supplemental doses have generally been safe in clinical trials lasting weeks to months, but there is a real signal worth knowing about. In 2022, a case series from the Drug-Induced Liver Injury Network, published in the American Journal of Medicine, documented 10 cases of liver injury associated with turmeric supplementation. The pattern they identified is important. The injuries were typically hepatocellular, meaning they affected liver cells specifically. The latency between starting the supplement and the injury was between 1 and 4 months. And critically, the researchers noted a strong genetic linkage to a specific immune marker called HLA-B star 35:01. People carrying this marker appeared to be at substantially higher risk. The absolute number of cases is small relative to the number of people who use turmeric supplements. but the signal is real, it is published, and it is worth being aware of. This is not a reason to avoid turmeric in your cooking. It is a reason to be thoughtful about high dose supplementation, especially over long periods. Let me now put this all together. Turmeric is a real molecule with a real mechanism. Curcumin directly inhibits NF kappa B by blocking a specific step in its activation cascade. Its bioavailability on its own is poor, which is why piperine increases systemic exposure by 2,000%. The strongest human evidence is in arthritis, where standardized curcumin extracts at roughly 1,000 milligrams per day have shown effects comparable to some NSAIDs in multiple trials. Turmeric reshapes the gut microbiome, including supporting populations of Akkermansia mucinifila, the bacterium associated with metabolic health from Patrice Connie's lab. The safety profile is generally favorable for most people, but high-dose supplementation has been associated with rare liver injury cases, particularly in genetically susceptible individuals. If you want to enjoy turmeric in a way that aligns with what we know about the biology, here are the underlying principles. Combine turmeric with black pepper. Pair it with fat because curcumin is fat-soluble, which is why traditional preparations in curry paste and golden milk have always combined turmeric with oil, ghee, or coconut milk. Choose standardized